Hello everyone, I'm Colin Donnelly. I'm a surveyor within Civil and Environmental in ESB International. I'm Chief Pilot and one of 3 in-house certified by the Irish Aviation Authority for small unmanned aircraft operations. I'm going to talk to you about the application of drone technology and how we've used this to add value for our customers. There's been a lot of learning involved around the ESB International drone since we started using it. We actively partake in webinars, online tutorials, forums from DJI, the drone manufacturer, Pix4D, the photogrammetry software provider, ArcGIS and Autodesk. Mostly our time is spent figuring out ways to manipulate and filter huge data sets that the drone produces and make the process quicker or more accurate or find a better deliverable for our clients. Often we are dealing with many gigabytes of images or a point cloud that we created that's extremely detailed. This clip is from a flyover survey we completed of a 400 kV line in County Sligo. My colleagues and myself have been in talks with staff from the new university and a private consortium about establishing drone test sites throughout Ireland on critical infrastructure owned by the ESB group. The goal is to explore developing end-of-use scenarios in terms of deploying drones for more cost-effective approaches to monitoring and maintaining plant and infrastructure, autonomous defect inspection after storm events, real-time fault finding along networks and beyond line-of-sight inspections. The current ESB International drone was purchased in March 2015 for €5,000. It would have been very easy at the time to spend €50,000 on a drone, but we decided we'd check out the technology first before we invested much larger sums into something more advanced. The original purchase still offers great value for money. At the time there were annual survey jobs that were earmarked as being perfect for the drone. These were ash disposal facilities belonging to the solid fuel power plants and the coal stocks volume survey at Moneypoint Power Station. This is a geo-referenced orthomosaic of the coal yard in Moneypoint Power Station in County Clare. It's made up of 600 individual photos all stitched together. There's been significant value added to our work since the introduction of this technology. Cost reductions are important to everyone. With this relatively cheap piece of equipment, I can survey the coal stocks in Moneypoint Power Station in less than half a day. Traditionally, that would have taken one person 3 full days of climbing up and down huge stockpiles of coal to get a result that it's nowhere near as good as what I can achieve using this drone. This is a plot I produced for the power station showing the volumes of different classifications of coal that were stored in the yard that day. The use of the drone significantly reduces the amount of walking that has to be undertaken, thus majorly reducing the likelihood of any incidents that might happen. The safety aspect is very apparent when trying to survey coal stockpiles, range from 5 to 10 metres in height in a busy coal yard with multiple coal stackers and earth-moving machinery in operation. With the drone I can get a point roughly every 2 centimetres. I wouldn't care to think how long that would take using traditional survey methods. This is a flyover of a 3D model I created for one of the ash disposal facilities in County Clare. Note the complexity of the landscape where the ash was tipped in individual loads from the trucks. Using traditional survey methods of surveying the top and bottom of batters and spot heights in between is about as accurate as you can expect from a topographical survey using a GPS or a total station. Changes in grades and break lines can often be overlooked, especially when surveying stockpiles. With the drone data, I'm very confident the information gathered represents exactly what shape the terrain actually is. This is a fly-through of a model I created of a beach in County Wicklow. Given the speed that the drone can capture data, hugely reduces the amount of people needed to undertake surveys, and jobs that were taking days for teams of surveyors are now taking half the time, and in some instances less than half the time. This is a plot I created from the previous model. The task was to identify areas of erosion. This was completed in one afternoon and is fit for the purpose that we needed it for. There are other advantages to using data captured with the drone. Normally there is much more data captured than would be captured using traditional survey methods. Where this comes into focus is when another team or part of a team asks if I have any survey information relating to a site or an area because they want to get an idea how wide a river is or say how tall a building is. Normally that wouldn't have been in the original survey request, but as I capture excess amounts of data with the drone when I'm in the area, the chances are I'll probably have some information that they're looking for. It'll take 2 minutes to check, and most importantly will save another site visit. John mentioned briefly earlier on the stairs he designed in Wicklow from data that was captured using the drone. Here's the point cloud of the same area, captured using the drone, and I processed it in Pix4D. Here we have a flight plan for a job I was undertaking in Donnelly in England. Planning surveys in the office is important to make sure that all the areas get covered. I plan my missions using available online mapping in AutoCAD, output the boundary in a map file and upload to the drone controller before I leave the office. When I get to site, it's almost as simple as press go and the drone is ready to map the areas that I defined. You can see them there with the borders around them. This is a model of an entrance road to a wind farm in County Kerry. Outputs into Revit and CivilCAD and other modelling software are becoming run-of-the-mill procedure for us. Liam will talk more on this in a few minutes, but this particular drone survey was used to calculate felling areas, rock outcrops, and the point cloud was used for detailed road design and earthworks quantities. As with everything, there are some limitations. Adhering to some of the flight regulations can be difficult. In particular, applications to the Irish Aviation Authority normally take 2 or more days to get approved, meaning that spur-of-the-moment surveys using the drone to fly in or near controlled airspace are not possible. Keeping a distance of 30 metres from a person, vehicle or structure not under your direct control can be very difficult. Adhering to a flight distance limit of 400 metres can mean larger jobs have to be split into multiple jobs, thus taking much longer to complete. Surveying in adverse weather is not possible using ESB International's drone. The same can be said for a lot of mapping drones that are on the market at the minute. This is quite a large restriction here in Ireland, although the technology is changing fast and there seems to be some good weatherproof products coming in the near future. The processing power of the computers used to work with this data is almost as crucial as the aircraft itself. Saving lots of time in the field surveying can be replaced by huge processing times if the PCs used are not up to scratch. The drone has to be paired with a very powerful machine or its true value is not being realised. This is often overlooked. Larger jobs can regularly take up to 24 hours processing to get a result. As the drone is using a technique called photogrammetry, it's a tool that helps create a surface of what it can see. Long grass, thick scrub or thick cover are significant hurdles. In this case, traditional survey methods are still holding the floor. This is a 360-degree panoramic photo. I made this from stitching multiple photos together. It's possible to create many practical outputs from the data captured with drones. You can clearly see this from the slides I've shown. Overall, this technology, it fits into our organisation perfectly. It offers significant value and cost savings, and in some instances a much better product. It's becoming more and more ingrained in our projects from implementation onto completion. This is a Corduff in West Dublin. This is another 360-degree panoramic photo, and you clearly see there are lots of applications for this sort of information. Extremely useful. That took approximately 5 minutes to capture that, and I think it was about 1 hour processing it to get all that to stick together like that. I'm going to hand you over to Liam, who's going to talk about another part of our process in ESB International. Thanks.